All right, let's go over the answers to Part A of the June 2019 Chem Regents exam. For question 1, which particles are found in the nucleus of an argon atom? Well, in the nucleus of an argon atom, just like most atoms, you're going to have your protons and your neutrons. So that's fairly easy. The only one that might give you a problem is if they asked about particles found in the nucleus of hydrogen. So hydrogen with an atomic number of 1 only has 1 proton and 0 neutrons. But all the other atoms, for all the other elements, protons and neutrons. All right, question 2. We have these positively and negatively charged plates here. It's an electric field, and we have a particle that is going straight through. So that indicates then we have a particle that has no charge. So in the question, which particle remains undeflected when passing through the field? Well, that is going to be something that has no charge, which sure enough is a neutron. Question 3. How about the mass of an electron? Well, you should know the mass, the charge, and locations for your protons, neutrons, and electrons. The mass of an electron is so small that we say it's essentially zero. It is not zero, but we say compared to protons and neutrons, which have a mass of 1 atomic mass unit, that electrons are extremely, extremely less mass, which is choice 4. For number 4, compared to the energy of an electron in the second shell of an atom of sulfur, the energy in okay, so sulfur has electrons in 3 shells. It is 2, 8, and 6. Sulfur, if you don't know the symbol, is letter S, and that can be found on reference table S, the element name and the symbol. As far as the electron configuration, you don't have to guess. It is on the periodic table given to you in the reference tables. So the second shell has 8 electrons. We have 2 electrons that are closest to the nucleus and 6 that are further away. The further away electrons are from the nucleus of an atom, the more energy they have. So more energy on this end and less on this end. So our answer is 1. Moving on to number 5, we have the ground state of an atom, which an element has 7 valence electrons. Remember, valence electrons are your outermost electrons. All you need to do is to take these 4 elements, look up the electron configurations on the periodic table, and find the one that has the number 7 on the right-hand side. That is fluorine. Your halogens are all in group 17. They have 7 valence electrons. Sodium, phosphorus, and nitrogen are not in group 17. If you don't know the symbols for these as you're looking them up on the periodic table, real simple. Again, go to reference table S. All right, let's move on to 6. Question 6. Which information is sufficient to differentiate sodium from silver? Well, sodium is an element and silver is an element. They have a different atomic structure, so they totally have different properties. And of course, the masses, we could mass out the same amounts. We could have the volume the same amounts. But if I put sodium in water, it's going to react violently. Silver will not react at all. So the answer here, I'm circling everything, that's silly, is choice 3. All right, for question 7. Question 7 is talking about what is known as allotropes. Even though they never use the word allotrope, at least we haven't seen it on any Regents exams, they use what an allotrope is. Allotrope is when you have 2 forms, 2 or more actually, of the same element. You have different bonding, which means different molecular structures, and because the structures are different, the properties are different. So allotrope is one of those vocab words you have to know. A question like this seems to show up on every single Regents exam, and here again, different structures and different properties. I have a video. I'm going to go ahead and I'm going to put up here a link to that. Check out the most common words that you need to know the definitions of for the Regents. For question 8, we're looking at the first 5 elements in group 14, considered in order from top to bottom. So we'd be going this way. There are changes in both. So if you take a look, this is what I call a 2-for-1 question. They're giving you two answers, right, for every choice. What do we know about groups on the periodic table? Well, first of all, we know that valence electrons, the outermost electrons, will be the same in a group. Okay, so we're looking for changes in both. Well, valence electrons, the outermost electrons aren't going to change. Group 14, you're going to have 4 valence electrons. You always drop the 1 with groups 13 through 18, so 4 valence electrons. So choice 1, it can't be. There's no changes there. And the number of valence shell electrons in choice 3, it can't be. Then we're looking at choice 2, electronegativity values. That could be changing. Electronegativity values are on reference table S. And the number of first shell electrons. Well, that's not changing because by the time we get to the first element in group 14, which is carbon, carbon's element 6, the electron configuration is 2-4. So all the elements in group 14 start with 2 electrons closest to the nucleus. So the answer can't be choice 2 either. It's got to be choice 4. So the electronegativity values are changing and the atomic radii are changing. This, you might remember from class, is periodic trends. Now, I would suggest doing this with the periodic table open, but literally just go through each one by one. And remember, electronegativity values and atomic radii are on reference table S. Question 9, which statement explains why sodium bromide, NaBr, is classified as a compound? Well, what this tells you is you need to know the definition and some parameters for compounds. Compounds, of course, are 2 or more elements that are chemically combined, and it is a fixed proportion. In other words, the ratio of the different atoms of an element, which here is 1-to-1. That is your answer. Now, you could go through the rest of the choices, but the answer here is 1. Let's keep going. For number 10, which 2 terms represent types of chemical formulas? For chemical formulas, you have different ones like a molecular formula, you have empirical formula, structural formula. There's your answer, number 3. But these other choices, those are things that you need to know as far as vocabulary words. For example, fission versus fusion, oxidation, reduction. Fission fusion is nuclear, oxidation reduction is redox. Endo and exothermic has to do with energy. Endo energy in and exo energy out. So make a list of words. If you forgot their meaning, write down their meaning, look them up on the internet again, find them in questions, and keep on going. Let's work on question 11. Okay, so during all chemical reactions, you got charge, mass, and energy that are conserved. So the answer here is 2. Now, normally the way they ask it is which of the following is conserved in a chemical reaction? And the one that students miss the most is they forget about charge. But charge, mass, and energy are all conserved, in chemical reactions. It's a fact. So we're dealing with facts and definitions here, a little bit with the reference tables. Make a list. Make sure you know them. Let's go to 12. Degree of polarity of a covalent bond between 2 atoms is determined by calculating the difference in electronegativities. So electronegativity or electronegativities, that word is always going to show up at least once, maybe twice on a Regents exam, right? It's the atom's ability to pull an electron towards itself in a chemical bond. Make sure you know it. So as far as determining whether I have ionic bonds, polar covalent bonds, or non-polar covalent bonds, we're looking at differences in electronegativity. All right, let's move up to question 13. Question 13, which substance cannot be broken down by a chemical change? This is a way of asking which of the 4 choices is an element. So we're talking about the definition of an element. So you need to be able to recognize which of the 4 is an element. Now, element names and symbols are in reference table S. Play the matching game. If you don't realize ammonia, that's a compound. Methane, compound. Water, compound. Our answer here is magnesium. For question 14, which statement describes components of a mixture? So a mixture, by definition, is 2 or more substances that are physically combined. Portions can vary. Each substance retains its own properties. So with that information, now you can answer the question, and that would be choice 3, that the proportions can vary. All right, we're almost there, halfway through. Question 15, table sugar can be separated from a mixture of table sugar and sand at STP. Remember, STP means standard temperature and pressure. Table sugar and sand are going to be solids at room temperature. You're going to be able to separate these two, of course, is table sugar dissolves in water, sand doesn't. So what would you want to do? You're going to obviously put the mixture in water. The sugar will dissolve, the sand won't. You're stirring it just to make sure all the sugar is dissolved, and then you can filter out sand from sugar. And then, yes, what would you do? You would go ahead and you could filter it. So the answer here is choice 4 for question 15. If you answered it incorrectly and thought about distilling. Now, distilling will separate water from what's dissolved in the water, and it will also separate liquids because they have different boiling points. The problem is why you couldn't use it here for question 15 is you would distill the water over, but now you would be back to a mixture of solid sugar and sand. So the only choice here is choice 4. We're halfway through. Let's go to 16. Okay, question 16. We're talking about particles of an ideal gas based on kinetic molecular theory. Well, a couple of things here. No real gas. Whatever gas it is, a mixture of gases is ideal. Ideal gas, we have a set of conditions where we're saying or oversimplifying the behavior of real gases. And there's a list. And on that list, here is the answer that the volume that the gas particles themselves takes up, we're ignoring it. That's what they mean by negligible. I can't say the word very well. But basically, we're ignoring it. So the answer here is choice 1. Now, another big thing about ideal gases is we're saying that the forces of attraction between particles is not strong, it is weak. For 3 and 4, this really just has to do with phase. Particles that are closely packed in a regular repeating pattern, we would say that's the solid phase, not the gas phase. And then, of course, particles separated by small distances, that would be either liquid or solid. So this whole idea of ideal gases are conditions that we're saying or oversimplification, so we can go ahead and look at the behavior of gases and the calculations using the combined gas law. For 17, which two processes does a substance release energy? All right, so for phase changes, which all of these are, the way that I always remember this and teach my students is think about something like ice or butter. When you go to melt a solid, you have to put energy in for it to become a liquid. So solid to liquid, and then if you have water and you want to boil it, liquid to gas, that's the endothermic direction. And that makes the opposite, and let's get real fancy here, I'll do a different color. Gas to liquid or liquid to solid, that opposite direction is exothermic. Now what you're going to do is you're going to just go through the choices here. If we're freezing something, right, and releasing energy, let me back up for a minute, is exo. So we're looking for the exothermic direction. This lavender is a really pretty color, but it's hard to see, so let's switch that again. All right, freezing and condensation. Freezing, of course, we're going from a liquid to a solid, and we're going, condensation is a gas to a liquid. So sure enough, here's our answer right away. It's choice 1 again. Now, if we just go through the wrong choices, freezing and melting is going to happen here. Liquid to solid, solid to liquid in choice 2, right? One is endo, one is exo, can't be the answer. So choice 2 ain't the answer. All right, evaporation and condensation. Evaporation, going from a liquid to a gas. When condensation is gas to liquid. For choice 3, of course, that can't be the answer either. We already know it's 1. And then finally for choice 4, evaporation and melting. Evaporation is going from liquid to gas and melting solid to liquid. It's the wrong direction. So the only one it could be is choice 1. So what I'm trying to tell you, when you're dealing with phase changes and either energy being released or energy being gained, go ahead and think of something you know, solid to liquid, that's putting energy in, and just run it from there. All right, let's move on. We're looking at reference table I here, and we want to know when we have dissolving in water, which of the four is XO? Well, let's take a look. Here is the table, reference table I. I'm just showing you the part we need to know. And what we're talking about here is right in this block, these four choices. And what you see is sodium hydroxide is the only one that has the negative sign, and we're told that's the exothermic reaction. Your ammonium chloride, ammonium nitrate, and sodium chloride are all positive. That's endo. So the answer here, of course, is going to be the sodium hydroxide. Let's go back, and that is choice 2. All right, moving on. For question 19, we're looking at property of a molecular substance determined by arrangement of molecules. Arrangement of molecules, right? These are clusters of atoms that are bonded together. Arrangement of an element, etc. You're talking physical state. It's just a fact, Jack. Let's move on. Equilibrium. As soon as you see the word equilibrium, what's equal in an equilibrium would be the rate of the forward reaction and the rate of the reverse. And what's constant are the concentrations. All right. Now, neither one of those apply, of course, to this question. What this is asking is, well, what type of changes can we have equilibrium? Nuclear reactions only go in one direction. They are not a possibility for equilibrium, so cross those out. Then what is the answer? Is it physical changes only? The answer is no. Both physical changes and chemical changes can reach equilibrium. Let's move on to 21. All right, so for 21, it says which value is defined as the difference between the potential energy of the products, potential energy of the reactants. Well, this, folks, is the definition for heat of reaction. Heat of reaction, symbol delta H. On a potential energy diagram, if you remember, first of all, for potential energy diagrams, divide it up into thirds. So you have your reactants, you have your products, and then in the middle, you have what's going on as far as activation energy, the energy required to get the reaction started. Your delta H shows up as the difference between the potential energy of the products and the reactants, right? So you have to basically take the difference, and that is heat of reaction. All right, checking out 22, 23, and 24. For 22, the effect of a catalyst on a chemical reaction. Catalysts speed up reactions. Everybody knows that. But what catalysts do is somehow the reaction pathway, in other words, the reactants forming the products, changes, and it means less steps. What does it result in, though? Well, on a potential energy diagram, remember, we just broke it up into thirds, and the middle has to do with activation energy, and that's what happens. The activation energy gets lowered. In 23, chemical systems in nature tend to undergo changes towards, well, lower energy and higher entropy. Meaning lower energy states, they're going to be more stable. Higher entropy, which means randomness. It's a fact, know it. 24, atoms of which element bond to one another in chains, rings, and networks. It's an element that we study in chemistry. If you take chemistry in college, you're going to take at least a whole year of what's known as organic chemistry, and that is the study of carbon, or really carbon compounds. So the answer for 24 is carbon. All right, let's take a look at 25. What is the general formula for the homologous series that includes ethene? And you see here some equations with carbon and hydrogen. Anytime you're dealing with carbon, with hydrogens, and then maybe even other elements, there are 3 reference tables. Open them up before you keep answering the question. So let's just go ahead and do that right now. Okay, so reference table P, these prefixes here tell us the number of carbon atoms. We're looking for the formula for the homologous series, and here it shows up in reference table Q. Awesome. Ethene was the compound. The ene ending tells me it's an alkene, and if it was something like butene or pentene, the ene ending, again, right here. That's our general formula. Can't get any easier than that. The last table down here, reference table R, that has to do with carbons, hydrogens, and then other elements that would be on molecules, such as the halogens, oxygen, and nitrogen. Don't look at an organic question without referencing these three tables. Question 26. When fluorine becomes a fluoride ion, or F minus, that minus sign means that atom has gained an electron. That's choice 3, right? Fluorine is a nonmetal. It's on the right-hand side of the table. Nonmetals gain electrons, while metals on the left-hand side give electrons. So our nonmetals have our negative charges, and our metals have our positive. All right, for 27, which substance here is an Arrhenius base? By definition, a base is a compound that has hydroxide, so it's metals and OH. So right away, it probably pops out at you that here the answer is choice 3, which is calcium hydroxide. Don't get confused. You see an OH here. This is an acid. All right, and actually 1 and 2 are also acids. So we're going to take a look at the acid-base table. It's right there. Don't do any questions without going there. So let's do that. What I meant to say is don't do any acid-base questions without looking at the 3 tables that have to do with acid-base chemistry. That's the common acids, table K, common bases, and then your indicators. All right, so 3 of the choices were here under reference table K. They are acids, not bases. The only one that was listed as a base, here it is calcium hydroxide, right? One thing, however, with table L. For table K, all of the acids are Arrhenius acids. They also can be defined as acids from the alternative theory, known in class as the Bronsted-Lowry theory. For the common bases, any metal with OH is an Arrhenius base, is also a base based on the alternative theory, and you see the OH. The only one that's different here is ammonia. Ammonia is not an Arrhenius base. Ammonia is a base with the alternative theory. So just want to throw that out there in case they had given you ammonia as a choice. Also, don't forget, when you're dealing with indicators and pHs, check out reference table M. 3 more questions left. Let's do this. All right, for 28, in which type of nuclear reaction do 2 light nuclei combine to produce a heavier nucleus? That is the description of a fusion reaction. Fusion here is choice 4. Fission is the splitting apart. Positron emission and gamma emission has to do with natural radioactivity, and also alpha emission. Make sure you know all of the types of nuclear reactions, all right, and in this case, 28, it was choice 4. All right, we're at the end of part A. Let's check out 29 and 30. Question 29, relative amounts of energy released during a chemical reaction and a nuclear. All right, well, nuclear reactions literally blow chemical reactions away as far as the amount of energy that is released. So much more. It's a fact, Jack. Choice 4. Question 30, ratio of the mass of uranium-238 to the mass of lead-206. This is a fact. You need to memorize this, and this is dating geological formations. There are a couple of isotopes, radioactive isotopes, that you need to know what they're associated with. Know them. If you don't have any review notes or you would like some more, check out my website, nychemcoach.com. Here it is. If you scroll down and then you go to Regents Chemistry Review, just click on it and keep scrolling. You'll see Chem Regents notes. So I list detailed information of what you need to know for different topics. And then here is Regents Chem, the year in review, and then answers. All right, and there's also more on this website. So check that out. That's nychemcoach.com. If you haven't subscribed to my channel, please subscribe. Hit the notification button because I will be uploading the rest of the June 2019 Chemistry Regents exam and different videos throughout the year.